Good morning, children. How are you all? Welcome to my class. Children, we use in our daily life a large number of substances such as lemon, tamarind, common salt, sugar, and vinegar. Do they have the same taste? Have you ever tasted them all? Do they have the same taste? Let us recall tastes of some edible substances like lemon juice. How does it taste? It tastes sour. Orange juice, sweet and sour. Vinegar, sour. Curd, how does it taste? Sour. Tamarind, sour. Sugar, sweet. Common salt, salty. Amla, a fruit. Have you ever tasted it? How does it taste? It tastes sour and bitter. Baking soda, bitter. Grapes, sour and sweet. Unripe mango, sour. You find that some of these substances taste sour, some taste bitter, some taste sweet, and some taste salty. Based on their taste, we can classify them as acids and bases. So today in this session, we are going to learn about acids and bases. Curd, lemon juice, orange juice, and vinegar taste sour. Why do they taste sour? Because they contain substances which taste sour because they contain acids. The chemical nature of such substances is acidic. The word acid comes from the Latin word acere, which means sour. The acids in these substances are natural acids. What about baking soda? Does it also taste sour? No. Then how does it taste? Since it does not taste sour, it means that it has no acid in it. It is bitter in taste. If you rub its solution between fingers, it feels soapy. Substances like these, which are bitter in taste and feel soapy on touching, are known as bases. The nature of such substances is said to be basic. If we cannot taste every substance, how do we find its nature? Children, it is not possible to taste all the substances. Why? Because some of them may be toxic. Special type, then the question is that how we can taste every substance. If we cannot taste every substance, then how we are going to identify whether the given substance is acid and base? Let us see. Special type of substances are used to test whether a substance is acidic or basic. These substances are known as indicators. What they are known as? They are known as indicators. What are indicators? Indicators are special type of substances which are used to test whether a substance is acidic or basic. The indicators, what do they do? They change their color when added to a solution containing an acidic or a basic substance. For example, turmeric, litmus, China rose petals, etc. are some of the naturally occurring indicators. They are found in the nature. Now we will see some natural indicators around us. First, litmus, a natural dye. The most commonly used natural indicator is litmus. It is extracted from lichens. It has a purple color in distilled water. When added to an acidic solution, it turns red, and when added to a basic solution, it turns blue. It is available in the form of a solution or in the form of strips of paper known as litmus paper. Generally, it is available as red and blue litmus paper. Here we will do one small activity. Mix some water with lemon juice in a plastic cup or a tumbler or a test tube. Put a drop of the above solution on a strip of the red litmus paper with the help of a dropper. What do you find? Is there any change in color? Repeat the same exercise with blue litmus paper. Note down if there is any change in color. When you will perform this activity, you will find that when a drop of solution containing lemon juice put on a strip of the red litmus paper, there will be no change in the color of the litmus paper. Whereas when you will drop it on a blue litmus paper, it will turn the blue litmus paper red. So in this way, we can see that the red litmus paper is dipped in a solution to establish whether a substance is acidic or alkaline. In acidic or neutral solution, red litmus paper remains red. When an alkaline compound dissolves in water, it produces hydroxide ions which cause the solution to become alkaline. The main use of litmus is to test whether a solution is acidic or basic. Blue litmus paper turns red under acidic conditions, and red litmus paper turns blue under basic or alkaline conditions, with the color change according over the pH range 4.5 to 8.3 at 25 degrees Celsius. Neutral litmus paper is purple. Next natural indicator is turmeric. It is another natural indicator. We'll do one small activity. Take a tablespoonful of turmeric powder, add a little water and make a paste. Make turmeric paper by depositing turmeric paste on blotting paper or filter paper and drying it. Cut thin strips of the yellow paper obtained. Put a drop of soap solution on the strip of turmeric paper. What do you observe? You will observe when you put soap solution on turmeric paper, it will turn to red color. We know that acids are sour substances which have corrosive nature and change blue litmus to red. Similarly, bases are bitter in taste and change red litmus to blue. Here, litmus paper is an indicator which changes color with acids and base. Why does it happen? It happens because turmeric is a base solution. So when we put soap solution in turmeric paper, the turmeric paper turns into red color. Now next natural indicator is China rose. Collect some China rose, that is called gudhal in Hindi, petals, and place them in a beaker. Add some warm water. Keep the mixture for some time till water becomes colored. Use the colored water as an indicator. Add the drops of the indicator to the solution. What is the effect of the indicator on acidic, basic and neutral solutions? China rose indicator turns acidic solution to dark pink or magenta and basic solution to green. Now we have learned that acids turn blue litmus red and bases turns red litmus blue. Let us see what happens when an acid is mixed with a base. We are going to use an indicator you have not used so far. It is called phenolphthalein. Fill 1/4 of a test tube. Take a test tube and fill 1/4 of a test tube with dilute hydrochloric acid. Be careful while using it. Note down its color. Note down the color of the phenolphthalein solution also. Add 2-3 drops of the indicators to the acid. Now shake the test tube gently. Do you observe any change in the color of the acid? Add to the acidic solution a drop of sodium hydroxide solution by a dropper. Stir the tube gently. Is there any change in the color of the solution? Continue adding the sodium hydroxide solution drop by drop while stirring till the pink color just appears. Now add one more drop of dilute hydrochloric acid. What do you observe? The solution again becomes colorless. Again add one drop of sodium hydroxide solution. Is there any change in color? The solution again becomes pink in color. It is evident that when the solution is basic, phenolphthalein gives a pink color. On the other hand, when the solution is acidic, it remains colorless. When an acidic solution is mixed with a basic solution, both the solutions neutralize the effect of each other. When an acid solution and a base solution are mixed in suitable amounts, both the acidic nature of the acid and the basic nature of the bases are destroyed. The resulting solution is neither acidic nor basic. Touch the test tube immediately after neutralization. What do you observe? In neutralization reaction, heat is always produced or evolved. The evolved heat raises the temperature of the reaction mixture. In neutralization reaction, a new substance is formed. This is called salt. Salt may be acidic, basic or neutral in nature. Thus, neutralization can be defined as follows. The reaction between an acid and a base is known as neutralization. So, what is neutralization? Neutralization can be defined as the reaction between an acid and a base. Salt and water are produced in this process with the evolution of heat. We can represent it as the following reaction. Hydrochloric acid plus sodium hydroxide gives you sodium chloride plus water. Now we will see some examples of neutralization which we see in our everyday life. First, indigestion. Our stomach contains hydrochloric acid. It helps us to digest food, as we had learned in the chapter Nutrition in Animals. But too much of acid in the stomach causes indigestion. Sometimes indigestion is painful. To relieve indigestion, we take an antacid such as milk of magnesia, which contains magnesium hydroxide. It neutralizes the effect of excessive acid. So now have you understood why do we take the milk of magnesia when we have the acidity problem? Next, ant bite. When an ant bites, it injects the acidic liquid, that is formic acid, into the skin. The effect of the acid can be neutralized by rubbing moist baking soda, sodium hydrogen carbonate, or calamine solution which contains zinc carbonate. It will neutralize it.